Hey everyone, we are continuing with question 4. This is math paper 1 of the 2020 paper. And yeah, we're going to be doing some functions. This is the function part of the question. I believe it's this question and question 5 as well. And yeah, okay, question 4.1, we are given the function h of x, which equals to minus 3 over x minus 1 plus 2. This is a hyperbolic function, and with hyperbolic functions, which should come to mind are your asymptotes, and that is exactly the first question. It says write down the equations of the asymptotes of h. So what is the asymptote? The asymptote is a straight line, usually with hyperbolic graphs. It is either vertical or horizontal, and those are lines that your graph will not touch. So we will have a vertical and horizontal asymptote for this graph, and to get your vertical, we start with the vertical. Vertical is on your x value, there's an x value, and you can see it is going to be where you don't want your denominator to be 0, so this is where this over here is equal to 0. So let me just write out a bit. You probably shouldn't write this out, but that's where x minus 1 is equal to 0, because if you divide by 0, you're gonna run into all kinds of problems. So then we solve for x, we add 1 on both sides, so it's where x equal to 1, and that is your answer. This is your equation for your vertical asymptote. That's where x equal to 1. And then we can do the same with our horizontal, and this plus 2 here, that is your answer. It's where y equals 2, for exactly the same reason. I'm sure you know this, but let me just check to this out. So your graph is y equals to minus 3 over x minus 1 plus 2, and if you take your 2 over, it becomes y minus 2 equals to minus 3 divided by x minus 1, and then you can do a little cross multiplying here, so it becomes x minus 1 equals to minus 3 divided by y minus 2. And here we're in the exact same situation as the x, where we don't want this denominator to be 0, because that will lead to our answers being undefined and a lot of confusion. So that's why our graph never crosses these two lines, which is x equals to 1 and y equals to 2. That's your 2 marks. Okay, then we have 4.1.2, determine the equation of the axis of symmetry of h that has a negative gradient. So your axis of symmetry, this is another straight line, but not the vertical horizontal this time. It's more of a diagonal line, and this will this axis of symmetry will basically cut your graph in half, so that when you flip them, they will land perfectly on top of each other. And with a hyperbolic graph, you have 2 axes of symmetry, one with a positive gradient and one with a negative gradient. So in this case, they're asking for our one with a negative gradient, and the negative gradient just means that it's going downwards, so it will go from the top left to the bottom right. And if it was positive, it will go from bottom left to top right. So how will we determine our axis of symmetry? We're going to be using our asymptotes, because we know that our graph don't touch our asymptotes, but our axis of symmetry will go right through where these asymptotes intersect. So that's going to be at the position of x1 and y2. So we can then take this and calculate our normal straight line. Our equation for a straight line is y equals to mx plus c, where y is our y value, m is our gradient, x is our x value, and c is our y-intercept. So we have a set of coordinates here, so we can substitute these in. So it becomes 2 equals to m. M is given as a negative gradient, so we'll be using -1. Our x value is 1. And we don't have our c value, which is fine because we're using it to solve this. So this then becomes 2 minus 1 multiplied by 1 is -1 plus c. We solve for c, so c equals to the c goes over, so it becomes 2 plus 1 is 3. Therefore, our equation of the axis of symmetry is y equal to minus x plus 3. Alright, you see our m is -1 and our c is 3. And that is our answer. Okay, 4.1.3. It is asking us to sketch the graph of h, showing the asymptotes and the intercepts with the axis. So you could actually see where this was going. They were kind of asking you for all the little bits and pieces, and now they're asking you to put it all together. So we'll just sketch our graph. We start with our normal axis. That's our x. This is our y. Don't forget to label them. So we have an x over here. We have a y over there. Then we have our asymptotes. So we have them at x equals to 1. So it'll be over here. So normally we represent them with a dotted line. I hope this is coming out clearly for you guys. If not, I do apologize. And then our horizontal, which is y equals 2, which we can set about here. It's clearly not drawn to scale. Oops, yeah, I could feel that not go straight. And then now we draw our graph. Remember our equation is, let's get our equation, h of x minus 3. So our equation is h of x equals to minus 3 over x minus 1 plus 2. So we can see that our a value, or in this case minus 3, is negative. So our graph will go on this in this top left corner and in the bottom right corner. Of course, we still need our intercepts. And to get our intercepts, or where they cross our x-axis and y-axis, we can do simply let's start with y, our y-intercept. We do know to get our y-intercept, what we do is we make x equal to 0. So this will become y equal to minus 3 over 0 minus 1 plus 2, and this just simplifies to minus 3 divided by minus 1 is 3 plus 2 is 5. So here's 2, 3, 4, so 5 will be about here. And then we do the same thing for our x-intercept. We make y equals to 0. So we do 0 equals to minus 3 over x minus 1 plus 2. Take the 2 over. So we have minus 2 equals to minus 3 over x minus 1. We then multiply them together, so it becomes minus 2x plus 2, because remember this multiplies by each term, equals to minus 3. Let me just keep it all here. We then solve for x, continuing to solve for x. We take the 2 over, it becomes minus 5, so it's minus 2x equals to minus 5. We then divide by minus 2 to get x by itself, so it's x equals to 5 over 2, the negatives cancelling each other out. So 5 over 2 is 2.5, so 2 is 1, 2, 2.5 is about there. Okay, and now we just throw our graph. It's coming over here, very close to 2, but not exactly at 2. And then it will go through our y and continue up all the way to positive infinity. Oopsie. Excuse the drawing skills, guys. Yeah, they're supposed to go right through there, which is 5. Don't forget to label them. And then this one was 5 over 2. And then this one starts from negative infinity, very close to 1 and not touching. And then it comes all the way through here, goes through the axis, and then almost at 2 but not touching. Okay, not bad for a hand drawn. Of course, when you do this, use a ruler. Make sure your curve is nice and curvy, not this broken up mumbo jumbo I have. But I'm here to show you the method and how to remember to do all this little stuff on the side here. Okay, let's continue on to the next question. Okay, then we go on to 4.2. So this time, instead of us having to draw a graph, they're giving us a graph and asking us some information. They're actually giving us 2 graphs. They say the graphs of f of x, which is equal to half into x plus 5 to the power of 2 minus 8, and g of x, which is half of x, plus 9 over 2 are sketched below. So this over here is our f of x, nice parabola, and g of x, which is a straight line, of course. Okay, they give us 3 notes over here. It says A is the turning point of f. Okay, it's over there. And the axis of symmetry of f intersects the axis at point E, and the line G at D, which is M and N. So just that line over there. And then they say C is the y-intercept of f and G. So these graphs intercept at the y-intercept. It's good to know. 4.2.1, write down the coordinates of A. A we know is the turning point of f, and f is in this lovely form that contains the turning point coordinates within it already. So you can see that the coordinates of A is there for 5, but remember it's going in the other direction, so it's to the left hand side, so it's negative 5. And this minus 8 over here is to show that it has moved down 8 units, so therefore it is negative 8. There we go, simple. That is as easy as they get. Okay, 4.2.2, they also write down the range of f. If we go back to our graph over here, f is our parabola, and they're asking what is our range. Range is simply all possible y values. So we know that this graph only goes to minus 8, and it doesn't go below 9. So there's no minus 9, no minus 10. It only goes up until this point, and it goes all the way to positive infinity. So that means our range is where y is more than and equal to minus 8. Yep. That's how you get 1 mark. So that means at all numbers where y is more than and equal to minus 8, the graph exists, or it's in that range. There is another way of writing this, just different notation that means the same thing. You don't have to write this, but it's just for you to know. You can write it as square brackets, that means including minus 8 to infinity, positive infinity, but of course excluding positive infinity because it's not a real number. Okay, 4.2.3, calculate the values of m and n. M and n, of course, is the coordinates of point D, which is on the same line as our turning point, so they share the same x value. So that means our m is minus 5. Oops, I did write minus 5 here. Silly me. Okay, I hope no one commented. I hope someone commented. But yeah, it's supposed to be minus 5. Don't know why I didn't write that. And yeah, so our m value is simply equal to minus 5. We could tell that because it was on the same vertical line as our turning point or parabola. Okay, so now that we have our x coordinate, we just need our y coordinate, and we can see that this d value is on our straight line, so we can use our straight line to determine our y value or our y coordinate. So we're going to use so we're going to use g of x, which is equal to, in terms of value, a half x, 9/2. So it's a half x plus 9/2. So we're going to check where x is equal to minus 5. So we can do g of minus 5 is equal to a half minus 5 plus 9/2. This you can just type in your calculator, and that will give you 2, because this becomes 5/2. 5/2 plus 9/2 is 4/2, which simplifies to 2. And then that means that our n value is equal to 2. Moving on to calculating the area of OCDE. Okay, so we have OCDE. So it's this little area over here. Can I just shade it a little, make you see? Okay, it's just that nice area. And so there's a few ways of calculating the area of this. You can use the area for a trapezoid, which is half the short side, into the short side, plus the long side, all multiplied by the base. That's a decent one. Okay, let's just do it. So we can use area with trapezoid, which is half. Let's call the short side plus long side multiplied by your base. Okay, now we just need our units for that. Okay, and this would be, of course, OCDE, the area of that. And so now we need the short side, which is D, the distance between D and E. We already have the value of n, which is the distance between ours from 0 to D, the point D. And n, of course, we have is 2. So we can put this in here. So it's a half. Our short side is 2. Our long side is from 0 to this point C, which is also our y-intercept. And using this straight line, we know that the C value here is our y-intercept, so that's 9/2. So we can put our long side as 9 divided by 2, and then we multiply this by the length of our base, and the length of our base is from the origin to the point E. Point E is, of course, -5, because that is our x value at both the turning point and point D. So -5 is just 5 units, because remember it's not negative, just 5 units. It's a distance. You don't get negative distance, you just have it in another direction. Okay, and then you can simplify this. You can type all of this into your calculator, and you would get the answer of 16.25. Right? That's one way of doing it. It's very straightforward. The only odd part, I would say, if you weren't familiar, if you didn't know this area of a trapezoid going in, if you didn't going in, there is a different way of doing it, but you're gonna have to be creative with your shapes now. So one way you can do it is taking this whole triangle over here. Oops, excuse the drawing skills. And then, you know, the area of a triangle is half times base times height. So you would take this area and minus this area, because that remaining area would be this OCDE. And yeah, let's just do it quickly. Hopefully I don't have to cut this out. So it would be big triangle minus our smaller triangle, and yeah, the area, just do area of the big triangle minus the area of the small triangle. A for the area. Okay, this is horrible. This is a better way to see it. So then it will be OCDE equals to area of the big triangle, which is a half base times height. Okay, now we just need our base and our height. So our base would be from this point to our A-intercept, by the look of it. So we need to calculate where our A intercepts with our x-axis, and to do that we need to make y equals 0. So let me just do it here on top so it can be easy to see. So this is for f of x, so it's where x intercept, that's where y equals to 0, so it is 0 equal to a half x plus 5 power 2 minus 8. We then solve for x, so we take the 8 over, so it becomes 8. We can also multiply by 2 on both sides, just to speed things up. So it becomes 16 equals to x plus 5 power 2. We then expand this and take the 16 over, so it's 0 equals to x squared plus 10x, because it's x times 5 times 2, and then 5 times 5 is 25, and then we're minusing our 16, so it's 0 equals to x squared plus 10x. 25 minus 16 is 9. Yeah, and we're doing all of this just to get our base. So we then factorize. So this becomes x over here, x here. It's 9 and 1, all positive. So 9, 1 plus x equals to minus 1, and x equals to minus 9. So that means if we look at our graph over here, our first x-intercept is minus 1, and our second one is minus 9. So that means the distance from our origin to this point over here is 9 units. So going all the way back, we have now our base is equal to a half, 9. Do we have our height? Our height would be c over here, and we have c, I believe, which is from our previous one, 9 over 2, was it? Yeah, like long side. Yeah, 9 over 2. So this is 9 over 2, which is then equal to, you can type all of this in your calculator. 9 times 9 is 81. 2 times 2 is 4. Can't simplify that. Okay, and then we're going to be minusing our smaller triangle, which is also half base times height of our smaller triangle. The base of our small triangle. So this one's at 9. This is at the smaller triangle starts at point E. E we have marked as 5. So let me just write this in here, minus 5. So the distance between minus 5 and minus 9 is 4 units. So this over here, we have a base of 4. And our height is from E to D. Our in value is 2. So it's a height of 2. So this becomes 2 over here. So this simplifies to 4 times 2 is 8, divided by 2 is 4. So it's minus 4. And then it's 81 divided by 4 minus 4 gives us the exact same answer as 16.25. Yeah, so this is much longer. This is a lot of work for 3 marks. But that's of course if you didn't know this little equation here. And yeah, and I think that's good for now. I think there is another way you can do it. I'm probably not going to do it because I did give you 2 ways already. But you can draw this line over here and then do a rectangle, and then that's base times height, and then add to that this new triangle over here, and that's another way of getting. You should get 16.25 as well. Okay. Yeah, that was a lot of work for 3 marks. Okay, 4.25. Determine the equation of g to the minus 1, that is the inverse of g, in the form of y equals. Okay, so if we get our g, which is just a straight line here, half plus 9 over 2, so it is g of x equals to a half x plus 9 over 2. I'm just rewriting it so I don't have to go look up again all the time. So to get the inverse, a nice little trick is to swap our y value and x value. So we would have it as x equals to a half y plus 9 over 2, and then we solve for y. So if we do that, we're going to have a half y equal to x minus 9 over 2. We then multiply 2 on both sides, so we're going to be left with, let me just write over here, y equal to 2x minus 9, because the 9's cancel. So therefore, that's our answer. They want it in this form. So just to write it clearly, we know that g, or the inverse of g, is therefore y equal to 2x minus 9. There we go, another 2 marks. Okay, 4.2.6. The question is, if h of x, which is a new function, is equal to the inverse of g, which we still have our previous question, plus k, is a tangent to f, a tangent being a straight line that only touches a curve once, or at one point. Determine the coordinates of the point of contact between h and f. So let's just simplify h of x. So h of x is equal to g of x, or the inverse of g of x, which can replace as 2x minus 9 plus k. And then we know that when two graphs make contact at the same point, they are equal at that point because they both have the same x and y values. So we can then say that h of x is equal to f of x to f of x. So we have h of x, which is 2x minus 9 plus k equals to f of x, which we can go get on top, of x plus 5 squared minus 8, I believe. Let's check. Yes. Okay. We can then simplify this, make it look much better. So we'll multiply this out first, the square. So we have 2x minus 9 plus k equals to half x squared plus 10x plus 25 minus 8. Okay, continue simplifying, multiplying the half in, and then I'll move all of this over, so it becomes 0 equals to a half x squared plus 5x, because that's 10 divided by 2, and then plus 25 over 2. I think it's better if we just leave it like this for now. Minus 8 minus 2x, this is all the terms we're bringing over, plus 9 minus k, and then we just add like terms, so it's 0, so it's 0 equals to a half x squared. We have 5x and we have 2x, so that becomes plus 3x, and then we have 25 over 2 minus 8 plus 9, so that's 1 plus 25 over 2, which is plus 27 over 2, and then minus k by itself. Okay, so at this point we can determine our x value by using the equation for turning point, which is minus b over 2a, and therefore x equals to minus 3 over 2a, which is a half, This basically cancels, which will equal to minus 3. Therefore, our x value is minus 3. So if you're thinking, what do we do with the k value? The k is pretty much constant in this point, which affects our c value, because it is a quadratic, ax squared plus bx plus c. So this whole here forms our c. So it doesn't really have an effect. We're only using the b and the a, so that doesn't really affect our determining of x in this point. Now that we have our x value, we can take this and put it back into our original if. So we have if of minus 3 equals 2/2 x plus 5. Oh, but x, we're not x, so we're substituting over minus 3, so it's minus 3 plus 5 squared minus 8. It's all numbers, so we can put that into our calculator. So our y value is then minus 6, and therefore our coordinates for the point between h and f is minus 3 and minus 6. Okay, that's a tricky 4 marks there. Yeah, this k really throws you off, but if you stick to what you know, you should be fine. Alright then, thanks for watching, see you in the next one.